Hi, in the previous videos, we built AI agents that could use tools. But there was a big limitation. The agent forgot everything after finishing a task. Real AI assistants must remember what they have already done. Today, we will build our first stateful AI agent with memory. Why memory is essential in AI agents? Let's understand it. Memory is foundational in creating AI agents that can operate reasonable across extended interaction, workflows, or problem solving sequences. One major advantage of incorporating memory is that it allows agents to track progress and avoid repeating previously completed steps, especially in scenarios where tasks span multiple iterations, such as executing multi stage calculation, recalling user preferences, or processing multi document instructions. Without memory, the agent behaves like stateless function, making decisions slowly based on the most recent input, an approach that is insufficient for application requiring continuity or accumulated understanding. So memory allows an agent to track progress, avoid repeating actions, make better decision over time. Without memory, agent behaves like stateless functions. All right, so let's define the goal. So what I'll do, goal equals to tell me today's date and then greet me using that date. Okay, so this goal has two steps. The agent must first fetch the date, remember it, and then use it to greet. So this is why memory is required. So what I'll do, I will create a memory structure. Okay, so for that, memory memory equals to then date none comma completed underscore task, then and close. Let's run it. Okay, so this directory represent the agent's memory. Date stores information about the agent learn, and completed task track what agent has already done. So in real systems, this memory could be a database or vector store, but the idea is exactly same. Now we will define agent brain. So for that, what I'll do, def agent underscore brain, and I'll pass goal comma memory memory, and then print and current memory, then comma memory, and if memory, then I'll pass date is none, then return ACTI1 action get underscore date. Okay, if GRWT degraded not in MEMORY memory, then completed underscore task, and return RETURN action greet, and return ACTION action done. Alright, let me verify. Okay, so this function is the brain of agent, that the one that we have defined. It does not execute tools, it only decide what to do next. So first the agent checks if the date is already known. If not, it decides to fetch the date. Then it checks whether greeting is already done. If everything is completed, it stops. And this is how memory influence decision making. So now let's define the tool. So for that, I will import date time, and then I'll define get underscore date, and then return date time dot date dot today dot strf time, and parameter we will pass t comma y. Again I'll define greet, and we'll pass date, and then return hello, today is, and I'll pass date, hope you have a great day. Alright, so let me verify. Okay, and run it. Okay, so these are tools the agent can use. The agent does not care how they work internally. So it only cares about what result they return. So this reinforce agent versus tool separation. Now what we will do, we will define agent loop. Okay, and for that, for step in range 5 and DECISION decision equals to agent underscore brain, and will pass goal, then MEMOR memory, then print agent DECISION decision, comma DECISION decision, then if DECISION decision equals to action get underscore date, then MEMORY memory, then date equals to get underscore date, then memory, then COPLET completed underscore task dot append and date underscore fetched fetched, and then we'll print date stored in memory, comma memory, and we'll pass date. Okay, now else if DECISIVNT season to action greet, then GREETING greeting is to greet, and then MEMORY memory date, and okay, memory, then completed, completed underscore tasks dot append and DRWTED greeted. Okay, and then we'll print GRWTING greeting, comma GRWTING. All right, else break. Okay, let me verify it and let's run. All right, so this loop is agent life cycle. We'll go through step by step and we will understand. The agent checks its memory, and the brain decides the next action. The action is executed using a tool, and results are stored in memory, and loop repeats. So this is what makes agent stateful. So notice what changed compared to earlier agents. The agent remember what it learned. It avoid repeating work, and decisions improve over time. So this is the foundation of AI assistant, co-pilot systems, RAG agents, and long-running AI workflows. Now let's understand stateless versus stateful. Understanding the distinction between stateless and stateful agent is crucial for designing intelligent system capable of long-term task execution. Stateless agents operate solely on immediate inputs, ignoring any information from previous interactions. This approach has limitations. It restricts the agent's ability to maintain coherence, forces repetitive prompts, and makes multi-step problem solving nearly impossible. For example, a stateless assist asked to build a three-part report must be instructed separately for each part because it cannot recall outcome from earlier steps. In contrast, stateful agents maintained a structured memory store that persists across interactions, enabling them to reference prior action, user preferences, and immediate result. This persistent memory form the basis for continuity, much like how humans rely on mental notes or historical context to make informed choice. One of the most notable advantages of stateful agent is that ability to coordinate dependent tasks. For instance, fetching today's date, storing it, and then gathering a greeting that use the stored output. So these differences from conceptual fundamental for building AI assistant that behave constantly over time rather than resetting after each query. Tools versus agents. Let's understand it. In a well designed AI architecture, tools and agents serve distinct roles that together enable robust, scalable, intelligent systems. Tools are specialized modules responsible for executing specific tasks such as retrieving information, performing calculation, calling APIs, or manipulating data. They do not decide when to run or what to do next. Instead, they function similarly to utilize invoked by external controller. Agents, meanwhile, operate at a higher level, determining which tools to be use based on context, goal state, and stored memory. This separation allows for modular design where tools can be updated, replaced, or extended without altering the agent's decision logic. For example, an agent may rely on a date retrieval tool to fetch the current date, but does not need to know how the tools collects this information. This abstraction improves scalability, enabling developers to plug in new capabilities without rewriting the agent. So, memory management principles and best practices. Let's understand it. Effective memory management is crucial for maintaining the performance and reliability of stateful AI agents. One common approach is implementing forgetting mechanism that remove outdated or redundant entries, which is aligned to how human disregard irrelevant detail to focus on current task. Another key consideration involves differentiating between short term and long term memory. Short term memory may include transient task information needed only for current workflow, while long term memory store durable knowledge such as user preferences or high level task summaries. So, carefully designing these layers steps help prevent overload and improve agent performance. So, overall summary is stateful AI agents represent a major advancement in intelligent systems designed by enabling machines to retain context, reason over time, and execute multi-step tasks with greater reliability and coherence. This distinct feature, persistent memory, allows them to track progress, avoid redundant actions, and incorporate accumulated insight into decision making. This capability is essential for real world applications such as automated research, workflow orchestration, customer support, strategic planning, and enterprise copilots. So, today we build our first AI agent with memory. In the next video, we will go beyond memory and connect agents to rack. So, see you in the next video. Thank you.